Hello everyone, welcome. In this video, we will be solving an Abia State University Math 102 Calculus 2 Pass Examination question from the Faculty of Engineering, Department of Electrical Electronic Engineering. As usual, I will be taking the question step by step, explaining the concepts and formulas involved so that you don't just get the answers, but actually understand how to solve similar questions on your own. Let's start with question 1. Now, pay attention. Question 1 has 3 parts. You have 1A, you also have 1B, and 1C. We'll take them one after the other. Let's begin with question 1A. Question 1A says, evaluate the indefinite integral. Now you can see that this question is having 5 marks. Integral of 4x cubed minus 6x plus 5 with respect to x. Now let's get started with the solution. The question says we should evaluate this integral. Now before we start solving, notice that this is an indefinite integral. It is written here, indefinite integral, because there are no upper and lower limits. When I say upper and lower limits, I mean, let me show you with a simple example. For example, if we had something like integral of, let's have the upper limit to be 3, lower limit 1, 4x cubed. I'm repeating the same function you have there with respect to x. Then this one would be lower limit and 3 would be upper limit. This would be called the definite integral. Definite. It should be called definite integral. And after evaluating it between these limits, we have here 3 and 1. Our answer would be a definite value. So if the answer is 5, it's just purely 5. If it is 200, it's purely 200. If it's minus 700, it's just purely minus 700. That's what we mean by definite value. So we would not add any constant of integration. Do you understand? But in our equation, we have this one. So let's get this out of the board so we can start solving right away. So we have this in our equation. There are no limits given. We don't have upper limit and lower limits in this case. So what do we do? Because it does not have upper and lower limit, that is why it is called indefinite. If it has upper and lower limit, it is called definite integral. Now, whenever we evaluate an indefinite integral, our final answer must contain a constant of integration, which we normally use or represent with C. You may be wondering why we use this C. The letter C simply stands for an arbitrary. We call it arbitrary. Arbitrary constant. Now, in principle, another letter would be used to represent the constant. You could use A, you could use P, you could use any letter to represent this constant. But C is a standard notation commonly used in integration. Now, the reason we need this constant is that when we differentiate a constant, we get 0. For example, if I have the derivative of x squared plus 2 with respect to x, do you know that if I differentiate this, the result will be just 2x? Because I would differentiate this first, this x squared, to give me 2x. And if I differentiate this 2, I will have 0. So I'm supposed to have 2x plus 0, which is the same thing as 2x. Also, if I take the derivative of x squared plus 2, I think I just did that, let's say plus 5 with respect to x, the result of this will just be 2x. Remember, the derivative of x squared will give you 2x, and the derivative of 5, which is a constant, is 0. Let me do one last one. What if I have the derivative of dx? Somebody should say the answer in the comment section. Minus the derivative of x squared minus 10. with respect to x. What would be the answer? Pause the video and let me know in the comment section. Exactly. If you mention 2x, you're absolutely correct, because this 10 is a constant and the derivative of a constant is 0. Even if we have it as -0, it's still 0. So if we're given 2x and asked to integrate, if we are given this 2x as our answer and we're asked to integrate 2x like this, we're asked to integrate 2x with respect to x. Of course, by the time you apply the integration formula, which I'm going to show you, the answer will be x squared plus a constant of integration. And this constant, we don't know what this constant could be. This C represents any constant. It could be 5. Remember this one, we have different constant in these examples I've demonstrated. But in this case, we don't know what the constant would be. So we just use C, which stands for that word arbitrary constant, meaning any value can be used to substitute for this C. Does that make sense? Now, the basic rule we need here is the power rule of integration. The power rule tells us that when integrating x raised to the power of, or raised to a power, we add 1 to the existing power and then divide by the new power. So mathematically, when you have integral of x to the power of n, it could be any power with respect to x. The rule says that since you have x to the power of, you add 1 to that particular power you have already, existing power, and then divide both sides by the new power. Just divide, the function with the new power. Then what next? You add the constant of integration, provided n is not equal to -1. So let's apply the rule to our question. Now that I've established all this, we can start solving, because this is going to help us in the subsequent question we're going to be working on. That's why I took this little time to explain these things in details. Okay, so the question says evaluate the indefinite integral, the integral of 4 x cubed minus 6x plus 5 with respect to x. So we can integrate each term separately. That means we will take the integral of 4x cubed, that's the first term, with respect to x, minus we take the integral of 6x with respect to x, plus we take the integral of 5 with respect to x. That's what I meant by integrating each term separately. All right, so what do we need to do? We apply the formula I introduced to us, which is the integral of x to the power of n with respect to x. That's the power rule of integration, which will give us x to the power of n plus 1 divided by the new power, then plus c. Let's apply this to each term. But before you do that, keep in mind that we have these ones as 4 is a constant, 6 is a constant, 5 is a constant. I would like to bring them in front of the integral sign to keep things easier for us. So we have 4 integral of x cubed dx minus 6 integral of x dx plus 5 integral of dx. This point where I have dx, there is 1. There's an invisible 1 here, because 1 times the x is still the same thing as the x, and eventually that 1 will be transformed to x to the power of 0. All right, the reason is because I want you to understand what will happen there next when I will start solving, applying this into this formula. So let's do that real quick. So now you can see that x to the power of 3 is something like x to the power of n. So it means that our n is 3 in this case. In this case, here is a power of 1, which we don't usually write it out. It means that our n would be 1. In this case, remember it was 1 that is here. If you replace that with x to the power of 0, because x to the power of 0 is same thing as 1. So it means our n will be 0. You can see how I'm taking this thing step by step. Okay, so what do we need to do in this case? We say 4 into, we're integrating right now, x to the power of 3 plus add it to 1 and divide by the new power. That's for the first term. Also, for this, we have x to the power of 1 plus 1 divided by the new power. Now, plus 5 into, remember I said x to the power of 0. That's the 0 is your new n. So that's the value of your n, 0 plus 1, or divided by 0 plus 1. And when you're done integrating like this, you add that c, constant of integration. So let's finish up with this. 4 into x to the power of 3. 3 plus 1 is 4. Let's put the answer directly. Divided by 3 plus 1, 4. Minus 6 into 1 plus 1 is 2. Divided by 2. Plus 5 into 0 plus 1 is 1. So x to the power of 1 is something as x divided by 0 plus 1 is still 1. More like 0 plus x divided by 1 plus c. Now the final answer, this cross out with this, leaving us with x to the power of 4 minus, this will reduce 6. 2 reduces 6 to 3 times this x squared, so 3x squared, plus 5 times, remember x divided by 1 is x. So 5 times x will give us 5x, then plus c. Now, this is the final result to this first question. You can see how simple this problem is, and we took it step by step. So our final answer is x to the power of 4 minus 3x squared plus 5x plus c. Remember, the c is important because we are dealing with an indefinite integral. So c is always important. Is that okay? And that takes care of question 1a. So let's move to question 1b real quick. Now we're asked to differentiate y equal to x squared multiplied by cosine x. Now question 1b is pretty straightforward. Now before we start solving, notice this expression contains two functions multiplying each other. The function we have, the first one is x squared. The second one is cos x, which is for cosine. Whenever we have two functions multiplied together and we want to differentiate them, we can use the product rule of differentiation. Product rule of differentiation. Please pay attention to that. And the product rule says that it tells us that if I have y equals uv, u is more like for x squared and v more like for cosine x, then it means that the derivative of y with respect to x will be equal to, keep this u constant and take the derivative of this v with respect to x, plus this time keep v constant and take the derivative of u with respect to x. You don't need to bother about what I just said. It is a formula I just quoted. So what you should be interested in is this formula. All right. So this is the formula for product rule. In simple terms, we multiply the first function by the derivative of the second function. That's simply what I did. Then add the second function multiplied by the derivative of the first function. That's exactly what I just did. So for this question, we assume that our u, or say let u be equals x squared, and we also say that v should be equals cosine x. All right, now let's differentiate each one separately. I will take the derivative of this u with respect to this x, and if you differentiate x squared, you have 2x using the general formula of differentiation. If you don't know about that, this is it. Differentiation of x to the power of n with respect to x equals n x to the power of n minus 1. This is the general formula. So we have to differentiate this x squared. So what do we need to do? What's the power you're having there? It's simply 2. So that means anywhere you see n, you plug in 2. That's what I did. So I have 2x to the power of 2 minus, sorry, take the minus up, minus 1, which gives us 2x to the power of 2 minus 1 is 1. So which is something as 2x. That's how I got this answer. I hope that is clear. All right, so please jot that down if you're not familiar with the basics or the fundamental of differentiation. You need to jot that down. Very, very important. Okay, so let's also differentiate this other one. Our v is cosine x. So if I take the derivative of v with respect to x, the derivative of cosine x is negative sine x. That's the result when you take the derivative of v with respect to x. Now we substitute this into the product rule. How do we substitute? It's pretty simple. Look at the product rule. Says this is a product rule here, says dy over dx equals, so plug in everything. Your u is x squared, so in place of this u you put in x squared multiply by, what is your dv over dx? This your dv over dx is found around here, dv over dx. The result is this negative sine x. So bring down negative sine x here. So use the appropriate sign you're seeing here, positive. Bring it down to this point. What next? You also locate your v. Your v is this one, and this is the value of v. Substitute that for v. And you also locate the u over the x, which is this one. Substitute this value. So let's do that real quick. So for my v, I will have cosine x, and then I'll substitute du over the x, which is 2x in there. Okay, so now let's simplify. We'll have dy over the x equals, if you multiply x squared by negative sine, you have negative x squared sine x, plus if you multiply this 2x by cosine x, you have 2x cosine x. Now we can rearrange the terms neatly. And what I mean by that is that this is having a negative value. So I want to bring this positive first and then this one second. That's what I mean by rearranging the term neatly. So I'll have dy over dx equals, I'll bring in 2x cosine x first, then minus x squared sine x. Hence our final answer is what you have in here. The derivative of y with respect to x gives us 2x cosine x minus x squared multiplied by sine x. So the derivative of this y equals x squared cosine x gives us this result. Pretty simple. And that takes care of 1b. Let's move straight to 1c. And this 1c is a limit problem. We asked to evaluate the limit lim x squared minus 9 divided by x minus 3 as x approaches. This thing means x approaches, or some textbook will say x tends to 3, or x approaches 3. So you need to be conversant with this terminology. This LIM stands for limit. Lim stands for limit. Okay, now before we start solving, let's understand what this notation means. When you have this lim as x tends to 3, what does it really mean? We are asking, what value does the expression approach as s gets closer and closer to 3? That's what it means. I'll repeat that. We are asking, what value does the expression, this expression, what value does this expression approach as this x approaches, gets closer and closer to 3? That's what it means. The first thing we normally try when evaluating a limit is direct substitution. What I mean by direct substitution is that since we have x approaching 3, the first thing I want to do is to substitute the value of 3 for, please, x approaches 3, we can still take it as x equals 3. That means anywhere you're seeing x, you can plug in 3 and see if you can get the answer directly. Sometimes it works. Okay, so let's do that real quick. So I'll plug in 3 for x and square that, minus 9 divided by 3 minus 3. And of course, 3 squared is 9. 9 minus 9 gives us 0, divided by 3 minus 3, and that will be 0 as well. Now we're having 0 over 0. This 0 over 0 is what we call an indeterminate. We call it indeterminate. 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 This is one of the indeterminate form. It means we have a lot of indeterminate form like infinity over infinity, 0 to the power of infinity, infinity raised to the power of 0, 1 to the power of infinity. Whenever you see 0 over 0 is called indeterminate form. What does it mean? What is the meaning of this indeterminate form? I said there are many kinds of or types of indeterminate form. What does it mean? Indeterminate means meaningless. It means when you have a 0 over 0, it doesn't make any sense mathematically. You can check on your calculator, just point 0 over 0 and tell me what you have as your result. Tell me what you have as your answer. You see that it makes no sense. So in that case, what do you need to do? You have to try using another method. Remember I said that when you have 0 over 0, this does not mean that the answer to the equation is 0. It doesn't mean that. It simply tells us that the direct substitution cannot give us the value of the limit in its present form. So we need to simplify the expression before substituting again. Now let's look at the numerator. This numerator you're seeing here is what we call difference of two squares. What I mean is that you can represent that as, watch, you can do it as limit of, I can represent that as x squared minus 9 can be expressed in exponent form as 3 to the power of 2. I hope that is clear. Still repeat the denominator, which is x minus 3 as x tends to 3. So the numerator is what gives us the difference of two squared. Look at the model. If I have a squared minus b squared, that looks like x squared minus 3 squared, isn't it? So the model is that you need to do this. You need to take the negative part. You can consider taking the positive part before the negative. Either one works. Such that if you expand this, it will give you back this. If I expand this, it will give you back. So representing this in this format, I will have x minus 3 into x plus 3. This is what we call difference. Difference of two squares. All right, it's actually a formula that you need to be familiar with. So in that case, let's apply that into our original problem and get the result fixed. Remember, this is the last problem for question 1. And if you need the question 2, you may need to check in the comment section. The link will be there. Okay, so what we need to do in this case, we say limit of x minus 3 into x plus 3. Please, if you want to read it, you can read it as limit as x tends to 3 of this particular function. So x minus 3 as x tends to 3. So most time I write it in different form, but the best way it should be written is starting off with limit as x tends to 3 of this function. So in this case, you can see that this can cross out. X minus 3 can cross out x minus 3, leaving you with x plus 3. So what do we need to do? This is where you need to substitute this again. So because you know that x approaches 3, anywhere you see x, you plug in the 3 plus this 3. And if you add up 3 and 3, it gives you 6. So it means that the result we have for this limit of limit as x tends to 3 of x squared minus 9 divided by x minus 3 is 6. The important thing to remember here is that when direct substitution gives you 0 over 0, we don't conclude that the answer is 0. Instead, we look for a way to simplify the expression. In this question, we did that by factorizing the numerator using the difference of two squares. And that takes care of question 1c and completes question 1a. So if you're ready with us, just be ready. We'll move to the question 2a. Until next time, see you. Bye-bye.